Hi, welcome to today's session on Fibonacci sequence. So the Fibonacci sequence is a very special sequence. It's not like the linear nth term sequences. It's not like quadratic sequences where those go by constant numbers. So what we call arithmetic sequences. And they're not the same as geometric sequences where it has common ratios. It has common multiples, which it's going up by. We call the Fibonacci sequence a recursive sequence. So this is the start of the Fibonacci sequence. Obviously, it goes on and on and on. It is an infinite sequence. We've got 1, 1, 2, 3, 5, 8, 13, 21. So each one of these is actually calculated by the two numbers beforehand, which are added together to give the next term. So here we're starting with 1, but our next number is 1. This is because if we look in front of our 1, we've got nothing there. So nothing had 1, that gives us 1. To get our 2, our next number in the sequence, we add our 1 and our 1. To get our 3, we've got 2, add the 1. To get our 5, we've got the 3, add the 2, and so on and so forth. This is actually a really good sequence because first of all, it's what we call a natural sequence. You'll see the Fibonacci sequence actually existing in real life, with things like nature, where if a flower petal grows, it can only grow out in this sequence. Flower petals can only grow out in between other flower petals, and it actually creates this sequence. Same as trees, but also on a maths point of view, this also gives us a basic rough estimate for conversion between miles and kilometres. Because here we've got 5 and 8, and 5 miles is roughly 8 kilometres. Here we've got 3 and 5. 3 miles is roughly 5 kilometres. I mean, when we're talking about conversions and talking about ratios, obviously we'll be talking about definite conversions, but this will give us a rough idea. So 8 miles is worth 13 kilometres. 21 kilometres is roughly 13 miles. So it has a good use. So just confirming that. And I'm just pointing out a couple of them, that they are using the previous two terms to give us the next term in the sequence. There is a rule that we can use to find a term in the sequence. To be honest, if you can understand that the next term is created by the previous two terms, that's the easiest way to be able to solve this. But for some of you, maybe doing higher level maths, maybe you've got to use the actual rule, in which case we've got Fn equals, in brackets, 1 plus the root of 5 to the power of n, minus, in brackets, 1 minus the root of 5 to the power of n, all over 2 to the power of n root 5. Now everywhere that we see the n's, this is where we're going to put the position of the term that we're looking for. So let's say that we're looking for the sixth term. Everywhere that we've got an n, we'll replace that with 6. And we know it should be 8 because 1, 2, 3, 4, 5, 6. We know the sixth term should be 8. So by replacing n with 6, looking to solve my sixth term, it does certainly equal 8. If I pull this out on a calculator, it certainly does equal 8. If you like what you see, please subscribe. Thank you very much for watching.